Alright folks, welcome back. Thanks for joining me. This is the second video in section 8 of unit 2 of AP Calculus, the product rule. We're going to pick up where we left off in the last video. We were doing some examples applying the product rule along with some of the other derivative rules that we've learned in previous sections. So we're going to pick up right where we left off, which was with Part E. All right, so Part E. So what we have here is we really have two products to look at in this problem. We're going to have this product, x to the fourth times the sine of x, and we're going to have this product, x to the third times the cosine of x, and we need to take the derivative of both of those things using the product rule. And one of the things that we're going to have to be careful of is this here minus sign, and making sure we subtract away the entire result when we take the derivative of x cubed cosine of x. So here we go, dy dx equals, and the derivative of x to the fourth sine of x is going to be x to the fourth times the derivative of the sine, which is cosine, plus sine times the derivative of x to the fourth, minus x to the third times the derivative of cosine, which is negative sine, plus cosine times the derivative of x to the third, which is 3x squared. Alright, so simplifying here, let's see what we got. We've got x to the fourth cosine of x plus 4x to the third sine of x plus x to the third sine of x minus 3x squared cosine of x. And by the way, when I'm writing polynomials along with trig functions, we haven't really talked about that prior to this video, I always like to put my polynomials first because it reduces the amount of what I like to refer to as notational ambiguity. I can tell that the 3x squared here is not inside the cosine because it's in front of it, whereas if I write it afterwards, it can become ambiguous whether the cosine contains the 3x squared or not. So that's just something to make your notation a little cleaner. And we do have two like terms that we can combine. We can combine those two middle x cubed sine of x terms to make 5x cubed sine of x. And ba-bam, we've got that as our answer. I would also consider, I frequently have told my students over the years that factored forms of derivatives are usually best, so I would probably go ahead and factor out an x squared here, since there's an x squared in every single term. And so I think that's an even better answer than the first answer that I gave, for practical purposes, when we start to apply these derivatives later. All right, let's look at part F. Now in part F, we've got an interesting situation here that we haven't encountered yet, because what we actually have is we have 1, 2, 3 functions that we're multiplying together using the product rule. And when we do this, what we need to do in order to do a problem like this is we need to group two of the functions together in order to apply the product rule. And you'll see what I mean here in a second. And by doing that, it'll enable us to we'll really use the product rule multiple times here. So what I'm going to do is I'm going to group together the e to the x and the cosine of x. And so I'll go ahead and start taking the derivative of this. And that's going to be x to the fourth minus 6x squared. And I'm going to even put an intermediate step in here, times the derivative of e to the x cosine of x plus e to the x cosine of x times the derivative of x to the fourth minus 6x squared. And this is a notation that I haven't been using an awful lot. Notice there's a big difference between this d dx and dy dx that we've seen in some other problems. This is, telling us take the derivative with respect to x of whatever is inside the grouping symbols to the right of this, this symbol. I forgot the word for symbol there for a second, sorry. All right, now, what that's going to do for us is now I'm going to have the first term, and when I take the derivative of the e to the x cosine of x, I'm going to actually apply the product rule doing that. So we've got a product rule inside of a product rule when we have multiple factors. And so this is going to be e to the x times the derivative of cosine, which is negative sine, plus cosine times the derivative of e to the x, which is e to the x. And then I've got e to the x cosine of x times the derivative of x to the fourth minus 6x squared, which is just going to be 4x cubed minus 12x. Okay, now, I'd like to maybe simplify this a little bit. I don't know how much real, true simplification I can do. But what it looks like here is, let's see, we've got dy dx is equal to x to the fourth minus 6x squared times the quantity negative e to the x sine of x plus e to the x cosine of x plus e to the x cosine of x times the quantity 4x cubed minus 12x. And I think really the only suitable factoring here that I can do is I can take an e to the x out of everything. I could go ahead and distribute these out and look for things to simplify, but I just don't think that there are any there. So what I'm going to do is I'm going to take a big e to the x out here, and then that leaves me with x to the fourth minus 6x squared times the quantity negative sine of x plus cosine of x plus cosine of x times the quantity 4x to the third minus 12x. And I don't know that we're going to get a better form of our answer than that. All right, couple of product rule examples, more complicated problems than the first few that we saw. Let's go on to the next page. For example 2, and now we're going to deviate from the product rule a little bit and kind of go back and review all of our rules, but do it with a numerical problem. What we've been given here is we've been given the value of the functions f and g, both at 1, and f prime and g prime, also both at 1, and we're being asked to find the derivative of h at x equals 1. So we're going to find the derivatives of all of these things using the rules that we know. So let's start with part A. The derivative of h of x equals 3f of x. So that's h prime of x. 3 is a constant multiple, and so the derivative of 3f of x is just going to be 3f prime of x. And so h prime of 1 is going to be equal to 3f prime of 1. And now we can substitute f prime of 1 in here, and we get 3/2. All right, part B. H prime of x, again, constant multiple, is equal to 2g prime of x. So h prime of 1 is equal to 2g prime of 1. And then I can go ahead and substitute g prime of 1 in there, which is negative 1/3. And I get my value of h prime of 1 in that case to be negative 2/3. All right, next, h of x is equal to f of x plus g of x. So that means that h prime of x is equal to f prime of x plus g prime of x. And therefore h prime of 1 is equal to f prime of 1 plus g prime of 1. And so let's see, f prime of 1 is 1/2. G prime of 1 is negative 1/3. We add those together and we get 1/6 for the value of h prime of 1. All right, let's keep plugging away. Part D, h of x is equal to f of x minus g of x. So take the derivative of that. Difference rule, and so that's just going to be the derivative of f minus the derivative of g. And so finding h prime of 1, that's going to be equal to f prime of 1 minus g prime of 1. And then we can go ahead and substitute the values in. F prime of 1 is 1/2. G prime of 1 is -1/3. This ends up being 5/6. By the way, notice we haven't used f of 1 and g of 1 yet. We've only used f prime of 1 and g prime of 1. All right, part E, h prime of x. We've got some constant multiples thrown in here, so this is going to be 5g prime of x minus 3f prime of x. And so h prime of 1 is equal to 5g prime of 1 minus 3f prime of 1. And then I'm going to substitute those values in. Let's see, g prime of 1 is -1/3, and f prime of 1 is 1/2. And so this turns into -5/3 minus 3/2, which is, let's see, that's 9 and 10, -21. Wait a second. -10/6 minus 9/6, -19/6. All right, and part F. Now in this one, we've got the product rule, so the derivative h prime of x is equal to f of x times g prime of x plus g of x times f prime of x. And so h prime of 1 is equal to f of 1 times g prime of 1 plus g of 1 times f prime of 1. And so we've got, let's see, f of 1 is 5, g prime of 1 is -1/3, g of 1 is -2, f prime of 1 is 1/2, and so that turns into -5/3 minus 1, or -8/3. All right, so those are some cool little problems where we can use, only knowing the value of the function and the derivative at one point, we can calculate the values of these combinations of those two functions, the derivatives of the combinations of those two functions. All right, let's see. I don't have a lot of time left. Got this one last problem here. Let's go ahead and see if we can hammer this out. Example 3, the graphs of f of x and g of x are shown to the right. If h of x is equal to f of x times g of x, find the value of each of the following derivatives. So h prime of x is equal to f of x times g prime of x plus g of x times f prime of x. And so h prime of 1 is equal to f of 1 g prime of 1 plus g of 1 times f prime of 1. Looking at the graph, okay, let's see. F of 1 is right here, it's 6. G prime of 1 is the slope of the g graph, which is -1/2. G of 1 is right here, that's 1.5 or 3/2. F prime of 1 is the slope of the f graph, and so that gives me -3 minus 3/2, or -9/2. H prime of 6, we'll put 6 in here instead. So we need f of 6, g prime of 6, plus g of 6 times f prime of 6. F of 6 is 1. G prime of 6 is the slope of that graph. That's +1/2. Sorry, I'm rushing a little bit because I'm running out of time. G of 6 is 6, and f prime of 6, of course, is still -1. And so this ends up being -11/2. And the last one, h prime of 2, is going to be f of 2, g prime of 2, plus g of 2, f prime of 2. And so we've got f of 2 is 5. G prime of 2 does not exist, and therefore h prime of 2 does not exist. All right, That's all we have time for, and that is the end of our lesson on the product rule. Please join me next time when we get into section 9 on the quotient rule. Have a great rest of your day, and I'll see you all then. Bye-bye.